Okay, class, I'm just going to finish up here. I wanted to go over just once again, just to rehash some of the things about the limits at infinity. So I know we went through this. I just want to remind you, remember the limit at infinity is when x approaches positive or negative infinity, okay? So, and then we looked at these, and really this was the key here. So noticing that for a function 1 divided by x, okay, as x approaches infinity, again, imagine infinity as a really big number, right? So it's going to be a large, large, large number, okay? But because x is approaching infinity, right? And again, if we divide 1 by a really big number, it's going to be 0, right? Because 1 divided by a really big number is so insignificant that we really don't care too much about it, okay? And then we said for any limit where 1 divided by x to some power greater than or equal to 1, it's going to go to 0. Again, because, the bigger the exponent, the faster the big number gets even bigger, okay? And then we talked about some limits, and I said we're just going to ignore those for now, okay? Then we talked about rational functions, and I gave you some tricks. Now, again, you can remember the tricks, okay? But you really want to, you have to be able to show why it is what it is, okay? So we went over a few examples in class. I'm going to skip down to some of the ones that we didn't do, okay? Or we talked about some of these, but we didn't really go through it, right? So again, you know that the limit is 0 here, for example, 6, but really we should be showing it out, right? So remember, to show how we're getting the limit, okay, again, what you'll need to do, we have to divide every single term by the largest power of x, okay, which is x cubed in this problem. So I'm going to divide the numerator by x cubed, right? And I'm going to divide the denominator by x cubed. Now remember, if you divide the numerator and denominator by x cubed, then you're just really dividing by 1, okay? So just again, to show what we're doing, you've got to divide every term by the highest power of x, okay? And then remember, all of these guys, right, because it's 1 over x, right, or if we simplify, right, we get 1 over x minus 3 over x squared plus 1 over x cubed. All of those guys are going to go to what? They're going to go to what number? They're going to go to 0, right? Okay, and one thing I also need to, okay, we got to rewrite the limit each time we do this. Okay, so I don't want to cheat you guys, especially guys moving on to AP next year. So now all those fractions go to 0, okay? Because the limit as 1 over a really big number is, again, 0. It's just a very small number, so it's insignificant to us, okay? So we get 0, right? But you already know that from the rule, right? The degree of the numerator is smaller than the degree of the denominator, so the limit was 0, okay? But notice how I'm writing it out, all right? And you will have to write it out on the test, okay? So I just want to let you know, okay? There's another example up here, right? This one where we're dividing by x cubed in the top and x cubed in the bottom, and we get 1/4. So look, you should know the answer right as you look at the problem, right? Okay, and then the hard part will just be probably showing how you got it, right? So let's take another one, right? So now we're going to add radicals into this. So, but it's a radical question, but the limit is at infinity, okay? So that That's what we're going to look at. Now, the highest power of x I see is x squared, right? But really, it's the square root of x squared. So really, the highest power of x we have is just 1. Because if I took the square root of x squared, I'd get x. So now, what I'm going to do here is I'm going to divide everything by the square root of x squared. And you may ask, Mr. Enzi, why are you doing that? Well, the reason is, if I divide everything by x, I'm not going to be able to do anything with the radical, right? Nothing's going to happen. So the square root of x, So if I have x plus 1 over the square root of x squared, okay? Now this becomes the square root of x squared over x squared plus 1 over x squared over x divided by x plus 1 divided by x, right? Because the square root of x squared is x. The only reason I use the square root of x squared is because I need to get into the radical here, right? If you did the square root of x squared plus 1 over x, the x cannot move into the radical, right? But when you divide radicals by other radicals, you can just make it one whole radical, right? They can move into the same house, if you will. Okay. So now, and again, equals limit as x approaches infinity. So limit as x approaches infinity. So now I have 1 plus 0 over 1 plus 0. So the limit is 1. Okay? Because 1 divided by 1 is 0. Now, the other way you can check is, again, so you're going to compare the highest power of the numerator and denominator. The highest power of the numerator is the square root of x squared. The highest power of the denominator is x. It gives me x over x, which is 1. So in your head, you should be able to do it right away. Okay, but you will have to write this out. Okay, so that's that. And let's do one more. So again, I have got a bigger one here. All right, x at limit as x approaches negative infinity of all this guy. So again, the highest power in the denominator is x cubed. The highest power in the numerator is x to the 6th. So again, because I want to get in the radical and simplify, right? What I'm going to do is I'm going to divide everything by the square root of x to the 6th. So 6x minus 6x cubed, square root of x to the 6th. Okay? Now again, since I divide a radical by a radical, and that square root of x to the 6th can move inside. So I have the square root of x to the 6th divided by x to the 6th minus 16x to the 5th over x to the 6th all over 6x over x cubed minus 6x cubed over x cubed. So on the bottom, I really don't need the radical, right? Because I can, the square root of x to the 6th is x cubed. And I can divide 6x and 6x cubed by x cubed. So on the top, I get the square root of 1 minus 0, okay? Because this guy is going to go to 0, right? Because the numerator, the power of the numerator is less than the denominator. And down the bottom, I'm going to get 0 minus 1. Okay? I'm sorry, 0 minus 6. Haha, forgot about the 6 there. And this gives me negative 1/6. Okay? Square root of 1 is 1. 0 minus 6 is negative 6. So I get negative 1 over 6. And again, you can check yourself by saying, all right, I'm going to compare these two powers, right? So I'm going to compare the square root of x to the 6th in the top. I'm going to compare negative 6x cubed in the bottom. that's really x cubed over negative 6x cubed, which is negative 1 over 6, okay? So I get the same answer. So you're going to have to do it the long way, but I'm going to show you the short way, just so you can check yourself, okay? Same thing here. If I wanted to, you're going to divide everything now. This one's going to be a little tougher, right? Because you have the square root of, or you have x cubed, right? So again, I'm just going to look at the higher power, right? The highest power, x squared over x cubed, right? 3x cubed. So you have x over 3x cubed, right? The limit is going to be 0 because the degree of the numerator is less than the denominator. Now, the long way, I'm going to have to divide everything by x cubed, but in the numerator, that means I would have to divide by the square root of x to the 6th, because the square root of x to the 6th is x cubed, but I have to get into the radical, right? Got to get in there somehow. So again, in the numerator, I've got both of those go to 0, and in the denominator, it goes to 3 minus 0, okay, which is 0, okay? So I just wanted to clear some of that up and show you the, mechanics of how to get what we were getting, okay? So I just want to reiterate, you will have to divide, okay? You will have to do those ones where, you're dividing by, divide the numerator and denominator by the highest power of x, okay? That's what we have to do. And then up here, right, we're going to know the answer before we even start, really, okay? Because if we look at it, we say degree of numerator is less than degree of denominator, 0. The degrees are the same. I'm going to divide the coefficients, okay, of the highest degree terms. And if the degree of the numerator is bigger than the degree of the denominator, it's going to give me positive or negative infinity, okay? So you should remember these, and you should be able to show why each of those work, okay, which is what we just went through, okay? That limit goes to 0. This one goes to a number, okay? And actually, let me do this last one here. Again, we're going to divide by the highest power of x, which is x squared. So this gives me the limit as x approaches infinity of 2x squared over x squared minus 3x over x squared plus 5 over x squared over x squared minus 2 over x squared. So again, all those guys where the numerator, degree of the numerator is smaller than degree of the denominator, they're all going to go to 0. So we have 2 minus 0 minus, or plus 0 over 0 minus 0. And again, you're probably saying, wait, Mr. Enzi, the limit used to be, if the denominator was 0, the limit doesn't exist, okay? But remember, for this case, it's only as x approaches a really, really big number, okay? So that 0 really isn't 0. It's really such a small number that we call it 0. But since it's a really small number, 2 divided by a really, really, really small number is just infinity, okay? Which is a really big number. All right, so that's all I got for you. Check Delta Math for your homework. If you have any questions, please reach out to me, and see you tomorrow. Actually, I won't see you tomorrow, but